Welcome, students, once again to the next lecture of satellite communication. As we finished the look angle, the range of the satellite, and the elevation and azimuthal angle of the satellite, now let us make a brief journey about the satellite communication, and as far as Indian scenario is concerned, how the satellite communication or the space communication has evolved and at what rate we are competing with the rest of the world in space communication, and some of the terms which we have familiar with satellite communication that we are going to discuss this in this particular class. So generally the question arises, what is a satellite? Okay, so when we talk about satellite, um, it is the an astronomical term or a object which rotates around some other planet. If we talk about the moon is the natural satellite which is rotating around the earth. Okay, but nowadays all we are launching different satellites into the orbit. So the same way the moon rotates around the earth, there are many artificial satellites has been launched which are also likewise moon are rotating around the earth. So in aerospace term, a satellite is a space vehicle launched by humans and orbits around the earth or another celestial body. But a communication satellite, if we talk, it is a microwave repeater. So when we talk microwave repeater, so why it is called a repeater? Because every transmitter and repeater is nothing but a transmitter and receiver. Okay, so it receives the signal, process the signal, and further it transmit the signal. So satellite is a such kind of repeater, which is a microwave repeater, which is located in the space, and it consists of different components like transmitter, receiver, amplifier, regenerator, filter, and multiplexer, demultiplexer, and as well as antennas are there. And hence satellite is a radio repeater, which is called as a transponder. So transponder is nothing but it is the combination of transmitter and receiver. Then how the satellite works? So generally satellite is a microwave repeater which is located at a very high altitude from the surface of the earth, and like the all base stations in we are installed, we have installed everywhere on the surface of the earth. So this repeater, which is a microwave repeater, it is not installed on the surface, but it is rotating around the earth in its own orbit. And there are many ground stations are there which are communicating with the satellites. So one of the ground station you can see in this diagram, which is a station on the earth and transmitting some signals to the satellite. And there is another ground station which is receiving at a different link, that is called as the downlink. And this is the communication link in between the satellite to the receiver. So when we are transmitting some information from the ground station to the satellite, so that link we name it as the uplink. And when we are doing the reverse way, that means when the ground stations are receiving some information or signals from the satellite, so that link is called as the downlink. Okay, and the point to note here that whatever frequencies we are using for the uplink communication, that means in order to transmit information to the satellite, Okay, so suppose you consider this transmitter. It is nothing but the transmitter of what do we say, Aaj Tak. Okay, so they collect the news information at different places and they transmit it to the satellite. Okay, and we have at our rooftop, we have a DTH antenna that receives the signal or all the broadcasting informations from the satellites. Okay, so this is the process what happens in satellite communication. But the uplink, we are using a frequency which is mostly around 6 gigahertz, whereas in downlink we are using a frequency that is about 4 gigahertz. But generally there is a convention that the uplink frequency is much higher than the downlink frequency. Okay, so what is the reason of such? I think why not we use the downlink? Why not we use the downlink with high frequency and uplink with low frequency? The reason is that if we are using a high frequency signal to transmit the information, then the power requirement will be more. So here we require more power to transmit the signal, correct? But if we transmit the same signal over a frequency of low frequency, then the power requirement will be less. So that means we require high power in order to transmit a signal with high frequency, and we need a low power in order to receive a signal over low frequency. Why we have taken? Because when the satellite is there, satellite has no power supply. We are not giving any power supply to the satellite, but it has its own power supply. We have picked some solar plates, and when the satellite is facing towards the sun, because satellite is rotating around the earth, some of the time it will face to the sun and sometimes it will face behind the earth. When your satellite remains behind the earth, okay, in such a way that the sun, the earth and satellite, they will make a straight line. Okay, in that case the satellite will remain in the opposite side of the sun, such that no sunlight will fall on the satellite. Okay, and in that case the solar plates will not be charged up, so that it will have no power supply. But in the other case, when the satellite comes uh, in front of the sun, that means your sun, satellite and the earth, they will make a plane. So in that case the sun rays will fall on the satellite, so that the solar plate on the satellite, they will store the energy. So those energy which has been stored by the satellite, so those energy will be utilized when the satellite comes behind the earth. Okay, so the power requirement is, or power scarcity is very high in satellite, because we don't have a permanent power supply to the satellite. So conservation of power is of high priority in case of space communication. So that is what, when the information is broadcasted by the satellite, so our aim is to transmit the signal, transmit the information at such a frequency, so that the power of transmission should be as low as possible. Okay, and it will happen only when we consider a frequency of we consider a link of low frequency value. So that is the reason for downlink communication we are considering the low frequency, but for uplink we are considering high frequency. And because here the power requirement will be high, and since ground station is on the surface of the earth, we can supply the power supply, we can give the power supply to the ground station. So at this point there is no scarcity of power, okay, but problem is here. So that is the reason why uplink frequency is high and low, downlink frequency is low for the satellite communication. And as I have explained the terms, what is uplink frequency and downlink frequency, those I have also mentioned here. Okay, so it uplink frequency we define that one when earth station transmit the signal to the satellite, and the reverse way the downlink frequency hits. That means the satellite transponder process the signal. Which signal? The signal which is coming through uplink frequency. That signal will be processed by the satellite and it will be transmitted to the second earth station. So that communication happens through downlink frequency. Coming to the advantages of satellite communication, it has advantages as well as it has also disadvantages. Okay, so what are the advantages? First one is the global availability. Okay, so that means communications satellites cover the large geographical area. Particularly if we talk about the geostationary satellites, if by using 3 geostationary satellite, whole earth can be covered. Only 3 repeaters can cover the whole earth. Okay, so means the coverage of those satellites is much more higher in comparison to any other repeaters, if we are considering the mobile repeaters or television repeaters. So these are having high coverage. So that the advantage is the customers which are located in the rural areas, um, and particularly the population density is very less in those areas. So they can be provided the service of communication service can be established through the satellite. The communication in the sense we can establish the communication like television communication. Mm, and you know, if you talk about the conventional earlier days, we had a television broadcasting station and we were installing some antennas. Those antennas are Yagi antennas we are installing. Mm, you know that I don't know whether you people have seen that kind of antenna. There will be a rod like this, okay, and this is the antenna. That earlier days we are using, this is called Yagi antenna. Okay, and sometimes if you are not getting good coverage, then we have to rotate that antenna uh, in some directions. So Yagi antenna is a purely directional antenna, right? Um, so this kind of antenna you cannot use everywhere. When you are using this antenna, so if the broadcasting antenna is nearer to this, then only you will get signal. But nowadays we are not using these antennas. Nowadays we are using satellite antennas. Okay, we are using the DTH antennas. So since the satellite has a broad coverage, you can use the DTS antenna everywhere or anywhere, any place you want. By using a DTS antenna, you can get the television signals. You also can have the internet access uh, through that. And second advantage is the cost effectiveness. So think when I talk about cost effectiveness, don't consider that the satellites are of less cost. No, initial cost while launching the satellite is very much higher in comparison to any other communication. Okay, we launch crores of rupees to launch a satellite, and so much investment we are doing here. But when we talk about cost effective means we have concerned that what is the cost per user. That is the meaning of cost effective. So if I am investing this much amount in setting up this communication, so how much users are being served or the service can be provided. So if we calculate the cost per user, then it will be very less in comparison to other. Because of its broad coverage, the high number of users can be provided. And another advantage is the number of users can be increased. There is no limitation. We can increase the number of user with time as well. Next advantage, if you see, then it will superior reliability. That means we have many other communications. We have telephone communication, we have mobile communication, we have fiber optics communication, and many more. But those communication, they are dependent on the infrastructure, and particularly if any natural calamity happens, the earthquake, or it will be flooded, or any natural calamity happens, all the communication links, they are temporarily damaged. Okay, so we cannot communicate with two particular pointer from one point to other point. Whereas in case of satellite communication, the communication link is throughout the year, and every time the link can be operated. And this link will remain active until and unless the satellite is active. And once the satellite is deactive, that means the life period of the satellite is over, then only the communication will break down. Okay, so next advantage is immediacy and scalability. As I said, the scalability, we can increase the number of receiver sites and networks. Okay, superior performance. So, superior performance means most, all the antennas, or nowadays when I talk about antenna, means nowadays we are using DTS, but in earlier days we are using Yagi antenna for television communication. So since the satellites are a geostationary Earth orbit satellite, so at an elevation angle of 60 degree, we can make a reliable communication possible between the ground station to the satellite. Okay, and the number of ground station we can increase day by day. Suppose today I don't have a DTS antenna, and if I like to uh, purchase one DTS antenna, then I go to market and directly purchase a DTS antenna. I can install on my rooftop, and even I can purchase 2-3 antennas of different companies. That also is possible. So that means you don't have to take permission or approval for increasing the number of receivers and transmitters. Okay, so then scalability is more flexible here. You can increase the number of users as per your requirement. Now as like advantage, so many disadvantages are there of satellite communication. So first of all, it is huge initial cost. The first time investment is very huge in satellite communication. Okay, second disadvantage is propagation delay, because in satellite communication where the communication link is of around 36,000 kilometer, which is very high, and so the propagation delay will be much more higher. Okay, and most probably the propagation delay is in the range of some seconds. Whereas if you talk about any other communication like mobile communication, you take an example, fiber optics, you can take an example. In those communication, the delay will be around some microsecond or millisecond. That is the delay. But here in communication, the delay will be in the unit of seconds. So much higher in comparison to other. And it is because of the large distance the signal is transmitted. Coming to next disadvantage, it is impossibility to repair. Yeah, so, in other communication, if you talk, we can repair if there is some damage happens to the communication link, or any damage happened to the happen to the repeaters or anything, then we can find out the point where damage happened, and we can go, and the engineer can go there and repair the uh, repeaters and any electronic equipments. But in satellite communication, once you have launched the satellite into the orbit, you cannot able to repair the satellite. Okay, and even once the satellite has been deactivated, that means when we are launching a satellite, the satellite is having some life period. Might be 5 year, 10 year, or 20 year is the life period. So once the life period of the satellite is over, so the satellite will keep on rotating uh, in the space. Okay, so like any other celestial body, it will keep on rotating. So we cannot repair the satellite, and or we cannot bring back the satellite to the ground station. And other disadvantage is noise and interference. Uh, when we are launching the satellite, it is rotating uh, within the galaxy, and in the galaxy so many noises are coming. So some noises are coming from the galaxy, that is from the sun, in forms of microwave radiations, infrared radiations. So these are the noises which are received by the satellite when they are moving in the galaxy. It has many applications. So as I have listed, these are the applications of satellite. If you talk about the orbit, and we also have talked many times, and we have done it in detail or in depth discussion on the orbit. If you see, this is I try to show the three-dimensional picture of the orbit. If you see the black circle, it represents your Earth. This is your Earth, and this is the satellite which is rotating around the Earth. So orbit can be defined as it is the path through which the satellite is rotating around any other celestial body. Okay, or the path through which it is rotating around the Earth. So that is called the orbit. So there can be many types of orbit. We also have discussed those orbit in details. So one orbit we can call it as the equatorial orbit, otherwise called the inclined orbit, and otherwise it is called as the polar orbit satellite. So this is the orbit. When this is the orbit, equatorial orbit means, suppose this dotted line represents the equator of the Earth. Okay, and the back side also you have the equator like this. So this is the this plane represents the equatorial plane. So if the orbital plane and equatorial plane, they lie on the same plane, then that is called then that orbit is called the equatorial orbit. Okay, that means exactly on the equator the satellite is rotating. Okay, and when I talked about equatorial orbit, but I am not here mentioning the term GEO. I am not telling that this orbit is GEO orbit or geostationary Earth orbit. No, GEO is also an equatorial orbit. Okay, GEO is also an equatorial orbit, but having an altitude of around 36,000 kilometers. That orbit is called GEO orbit. Okay, but if the satellite is rotating in the equator or equatorial orbit, and the orbit is at an height of 1,000 kilometer approximately, then we cannot call that orbit as GEO orbit. We may call that orbit as lower Earth orbit. Okay, that means all equatorial orbits are not GEO orbit, but all GEO orbits are equatorial orbits. Getting my point? Now, similarly, we have another orbit that is called inclined orbit. Okay, so it is not that all satellites are rotating on the equatorial plane. Some satellites are rotating in the inclined plane. Then you might have a question that why there is equatorial orbit, because see, it depends upon the location of the country. If India is somewhere, suppose you assume that India is somewhere here, okay, and North America is somewhere here. Okay, so as a country, India has no more relationship. It has we are not related to this, what is happening in these areas. Okay, if we want to make a communication between our country, the earth station of our country to the satellite, so we should launch the satellite such that this much portion, the satellite should cover this much portion. But whereas if there are other country, I mean like North India is here, okay, Europe will be here, Russia will be here, okay, and so you see Russia will be here, and as I discussed in the previous class, particularly for the countries which are present in the very northern hemisphere, so for those countries the elevation angle will be very small. Okay, if some obstacle will happen in front of their antenna, DTS antenna, then the signal quality will be very less. That is the problem. So what they will do, rather than depending on the equatorial orbit, so they will launch their satellite in some other orbit, can be inclined orbit or can be polar orbit. So polar orbit means Europe and thing they can communicate here. Okay, so it depends upon on which orbit or which location you want to communicate. Okay, nowadays that USA has launched many satellite and they are making they are making the surveillance on every part of the India, not only India, every part of the globe they are making surveillance, means they are watching what is happening in China, USA, and other parts also. So their satellites are everywhere. Okay, and I also want to tell that here, suppose this orbit can be a geosynchronous orbit. Okay, but all geosynchronous orbits are not GEO orbit. So geosynchronous orbit means the both the Earth and satellite moving at the same velocity. Okay, then that is called a geosynchronous orbit. But when the geosynchronous orbit lies on the equatorial plane, then only that is called GEO orbit. Otherwise, no. All right. So this is the the animation image I have shown how a satellite is rotating around the Earth, and this particular orbit is called the equatorial orbit. And you see that the plane is this plane is the equator of the Earth. Okay, and on the same plane the satellite is rotating. Okay, so this is Earth equator and this is the orbit that is called, this orbit we can call it GEO orbit, and only when you can call GEO orbit if the orbital height will be 36,000 kilometer. Okay, so only when the orbital height will be 36,000, then only we can call that as GEO orbit or geostationary Earth orbit satellite. But if the orbit height will be less, for example 1000, then we can call this as the low Earth orbit. LEO orbit. Okay, so you see here, if we have to observe the tropical weather patterns and we have to monitor the cloud conditions, okay, then the orbital height will be either medium or low, because we have to, particularly for weather and for surveillance purpose, remote sensing applications, we need the the image. Okay, so we have to install the image so that the images can be captured. Okay, but whereas for communication, we are using that microwave transceivers. Okay, so if you talk about the surveillance, or if you talk about the weather monitoring, we need a high pixel sensors so that the image and video can be recorded. So that means we are taking some optical information. So that's why those satellites are of lower height. And this is the inclined orbit, as I have shown. And like inclined orbit, there can be polar orbit satellite. So polar orbit means when the satellite is covering the north and south poles of the satellite. Many types of satellites we have discussed that I have highlighted here. So one can be called as GEO. GEO stands for geostationary Earth orbit satellite. And LEO stands for lower Earth orbit. MEO stands for medium Earth orbit. Then Molniya orbit satellite. Then a high altitude. What is that? I will see it. Okay, and we will discuss the frequency bands. The GEO satellites we have discussed, as we have discussed several times before. The orbital height will be 35,863 kilometer. We approximately call it as 36,000. And keep in mind, it is above the Earth's surface. Okay, it is not the orbital height of the satellite. From the surface of the Earth at this altitude, the orbit is present. But if you tell me what is the orbital height, then it will be 41,000 something kilometer. Okay. So objects in geostationary orbit revolve around the Earth at the same speed as the Earth rotates. This means geosatellites remain in the same position relative to the surface of the Earth. So that's why it is called as geosynchronous. Okay, so it gives a large coverage area, because as large the satellite will be present, so coverage will be that much larger. Okay, almost a fourth of the Earth's surface can be covered. So geosatellites have 24-hour view of a particular area. Oh, okay, because they are synchronous, they are relatively stable. So 24 into 7, they have uh, proper alignment from the Earth to the satellite. And what is the disadvantage? Since it is located at a very large altitude, the signal is very weak signal, and time delay will be much higher. Okay, so it will be very bad for point-to-point communication, and this is, I think, this is the only reason why for weather and remote sensing application, we cannot use GEO satellite. Okay. And if a geosatellite is there, any point which is near the polar region, they cannot able to properly communicate to the GEO satellites. Okay, so that's why they launch polar satellite or inclined satellites for their communication. Now we have the another satellites which are rotating in the low Earth orbit. So that is called, those are called as the LEO satellites. So mostly LEO satellites are rotating at an orbital at an altitude of 500 to 1500 kilometer, and many times I also told that it is how much I told where here I told 1000 kilometer. Okay, so it is around in the range of 500 to 1500 kilometer. But since they are very close to the surface of the earth, not very close because 1500 kilometer is not a near distance, you can see, because when we are traveling by flights, our flights are moving at an uh, altitude of around 10 kilometers, 11 kilometers approximately from the surface of the ground. I'm telling, at that much height the flights are moving. But you see, the those satellites are at 500 to 1500 kilometer. So don't think that they are very near. Okay, otherwise the satellites and flights, they will bombard with each other. Okay, so alien satellites don't stay in fixed position because from the very beginning when we started discussing on the Kepler's law, what we saw that the satellites which are rotating at a lower radius, okay, they travel at a very high velocity. Okay, that is what we have seen by solving an example also. So these satellites which are rotating in the lower Earth orbit, they travel with a very high velocity in comparison to the satellites which are rotating in mm, geostationary orbit or geostationary Earth orbit. So since they are traveling at a very high velocity, so if any point on the surface of the Earth you take as a reference point, so the satellite will skip out of that point very quickly. So if suppose one point is there and that point is the ground station on the surface of the earth, and the ground station is communicating with the satellite, and the satellite is an lower earth orbit satellite. So the satellite will immediately go out of the vision of the ground station. Okay, so in order to overcome this kind of difficulty, we have to launch a series of satellite in the LEO orbit. So once the one satellite goes away, immediately the next satellite can come for the communication. Okay, so that's why the most of the time the satellites which are rotating in LEO orbits, they will remain visible to a particular point on the surface of the earth for a duration of around 15 to 20 minutes. Okay, so that is why a network of LEO satellite is necessary for LEO satellite to be useful. Okay, and I have not remembered properly. Um, one of the well-known satellites, I think Erbium or something, because it had that those satellites are nothing but a series of satellites. It's a network of satellite, and how many number of satellites, it depends upon the atomic number of that material. Okay, uh, I cannot say it exactly, so, but I can I guess it is erbium or something like this. The name erbium has been given because I'm telling that it may not. I'm not sure it is erbium or what. The name erbium is given because of the atomic number of that my material. So whatever is the atomic number of the material, that many number of satellites uh, has has been launched in the network. Okay, you can make a Google search and find out uh, different LEO satellites. Okay. Um, yeah, LEO satellites, they cover a very small area. Okay. So that is the reason there are multiple LEO satellites has been launched. So if you talk about the disadvantages of low Earth orbit satellites, um, we cannot launch a single satellite. We have to launch a network of satellites. Network in the sense many satellites we have to launch. Okay. Um, the LEO satellites have to compensate for Doppler shift caused by their relative motion. Okay. That means if we are communicating um, from any Earth station on the surface of the Earth and the satellite, since the satellite is not a relatively stable, the satellite is moving, so the effect of Doppler shift will appear to the communication link between the Earth station and satellite. So due to Doppler shift, there will be a frequency deviation. If a satellite is, if a satellite is transmitting at some frequency, but at the ground station, the receiver will receive the same information at some different frequency. It happens due to Doppler shift. And next kind of satellite is called the medium Earth orbit satellite, which are around 8,000 kilometer to 18,000 kilometer from the surface of the Earth. They are moving, and they are having also same functionalities like the lower Earth orbit satellite. That means weather monitoring and remote sensing applications. The medium Earth satellites uh, have been launched. And comparable to the lower Earth orbit satellites, so of course, the coverage area of medium Earth satellites are much larger because the orbital height is quite larger in comparison to the lower Earth satellites. So obviously, they have a larger coverage, but they have not that much larger coverage than that of the GEO satellite, because GEO satellites, they have much broader coverage. Okay, and these medium Earth satellites, they remain visible for 2 to 8 hours. Okay, if as we have discussed here, the lower Earth satellites, they will remain visible for 15 to 20 minutes from any point on the ground surface. Okay, but these satellites, MEO satellites, they can be remain visible for 2 to 8 hours. And the advantages of MEO satellites is because they will remain visible for longer duration in comparison to LEO, and they have wider footprint. Footprint in the sense it is the coverage. And in comparison to LEO, we need less number of satellites when we are launching a network of satellite into MEO orbit. And disadvantage is its distance. So in comparison to LEO, it is located at a larger distance, which is around 18,000, 15,000 kilometers. So again, the delay will be larger. Okay, that means the quality of signal what we will collect from the MEO satellites, that may not happen from MEO satellites. So other type of satellites are called, another is called the Molniya orbit satellites. Particularly, these are the inclined satellites or the polar satellites, which the northern hemisphere countries are using, like Russia. Okay, they are using these satellites. So that is called the Molniya orbit satellite. So Molniya orbit satellite is the same type of GEO satellites, but thing is that GEO satellites are rotating on the equatorial plane, but MEO that this Molniya orbit satellites, they are not rotating on equatorial plane. They will rotate on some inclined angle. So these satellites, they will remain relatively stable. Okay, and mostly for 8 hours, most probably they will remain relatively stable. And this is useful near the polar region. And next type of satellites, which we called as the high altitude platform. So this is one of the current, kind of satellites, which is of newest idea, and they are launched at an orbital at an altitude, not orbital height. It is an altitude of 20 kilometer only. Okay, so can you imagine 20 kilometer? When we are traveling in flight, we are traveling at an altitude of 10 kilometer. Okay, so just double of that height. These satellites are moving. So it is they are moving at a very close to the Earth's surface. Okay, so that's the reason they have a very small coverage area, but comparatively we will get the very good signal, and we will have the very good quality of image or the signal quality from the satellite. And next thing advantage we can say, since the orbital height is very small, and so it will be very cost effective or cheaper to put the satellite into the orbital height. Okay, so this is one of the images to show you how the satellite communication happens and what other signals can interfere with the satellite communication. If it comes to the frequency band, we are using the microwave frequency band for the communication of the satellite, and mostly from 1 gigahertz to up to 40 gigahertz frequencies we are using for satellite communication. So those frequency band which is having the total bandwidth is 40 gigahertz. So the satellite communication has a total bandwidth of 40 gigahertz. So those 40 gigahertz bandwidth can be divided into 7 different bands. So one is called L band, S band, C band, X band, Ku band, K band, and Ka band. Okay, so these different bands are having different frequency ranges. For example, L band, it will range from 1 gigahertz to 2 gigahertz. S band will range from 2 gigahertz to 4 gigahertz. So like this, the total 40 gigahertz whole spectrum will be divided into seven types of bands. Okay, so you see each band is having their own bandwidth. If you sum up all the bandwidths, so you will get it as approximately 40 gigahertz. That is the total bandwidth in which the satellite communication is taking place. And what are the services the satellite communication provides are different frequency bands that has been listed over here. Now, coming to the Indian scenario, as far as India is concerned, we have launched the first satellite, that is India has launched the first satellite, that is called Aryabhat, in the year 1975. And that satellite was launched in inclined orbit. It is not an equatorial orbit, but India has launched in an inclined orbit. But if we talk about the circular orbit, then that satellite is called Bhaskar. It was launched in the year 1979 for the remote sensing application. But that satellite was launched in a circular orbit. But if you talk about the GEO, so the first GEO satellite what India launched in the year 1981, that is called as Apple. This is the first GEO satellite India has launched. Okay, although these information are not much relevant, but it is just to give you a brief idea that what the Indian space research is taking place. But as far as exam is concerned, these are not required to remember. Then again, the next series of Bhaskar and INSAT series came into place, which was the joint venture of Department of Telecommunication and Department of Space. And Also, India has launched many remote sensing satellites in the polar orbit. So these are different INSATs. So Intelsat. So Intel is not Indian satellite. It is an I think it is a um, combination of multiple countries. This Intelsat is a project where multiple countries are involved, and all the countries they launch the satellite. And Intelsat has the series of satellites. It's not one satellite. They have launched in different years. They have different versions. Intelsat 1, Intelsat 2, many versions of the satellite. It was launched. So around 140 nations they come together and they have launched, and whatever the service the satellites will be provided. So the all the countries, all 120 member countries, they receive the service from the Intelsat. And particularly the Intelsat has a whole globe coverage, like means it covers the Atlantic Ocean region, Indian Ocean region, as well as Pacific Ocean region. It has a coverage. So these are, if you see this, I have shown the images of the Intelsat. This is with their respective series, Intelsat 1, Intelsat 2, 3, 4, and in which year those satellites have been launched. So one thing I like to point here that if you observe the different years, you see the uh, communication payload. The payload means what the equipment the satellite is carrying, that is called the payload. We will discuss this thing in detail in module 2 and module 3. So if you see the payload, payload generally consists of what is the how many number of transmitter, receiver, amplifier, how many number of antennas, uh, and power amplifier. All those components, they constitute a payload. So if you see that as the series count is increasing, that means as with time progresses, the payload is increasing. That means day by day we are launching, we are sending the satellites with high weight, with heavy weight satellite and big satellites we are launching. Okay, so the if you see the first version of Intelsat, it was the payload was just 13 kilometer, but the sixth version of the satellite is having payload 800 kilometer, 800 kg. Okay, and in this image, I have not mentioned all the Intelsat versions beyond 6. Okay, I have shown only the 6th version because which is available in the internet. So beyond 6 also there are many other versions have come, like Intelsat 7, Intelsat 7, 7A, which were launched in 1993, 1996 respectively. Okay. So these are all about the brief discussion on the history and some terms related to satellite communication. So with this discussion, let us stop our uh, meeting today. And if you have any question, you can discuss with me.